All right, so yesterday we talked about t-distributions, yes, when you don't know your standard deviation. Today we're going to talk about confidence intervals for population proportions. And this is really, again, fairly easy. All right, pretty quick lesson. It's when do I use what is what's going to be more confusing for you. So, point estimate for proportions. So you're not going to be given a mean or a, you're going to be given the population proportion. Or you're going to find it. So this little guy with this little hat on is called p-hat. All right, it's kind of a weird, but it's called p-hat. That's how you would say that variable. And it's just x over n. So how many, let's say I have 300 people and I found that 100 of them watch Netflix. So the point estimate would be 100 over 300, or 0.33. Okay, so you're finding the proportion of the population that is in that category. Okay? So you're just dividing. You're finding the percent of the population. And that is the sample proportion. It's called p-hat. So it's not the mean of the population. You're looking at a sample and finding the percentage of that sample. So it's called a sample proportion. Or p-hat. So these relate to binomial distributions. If you remember binomial distributions, you have a p and a q. So if p-hat is 40%, what would q-hat be? 60%. It's 1 minus p. Okay? So q-hat's in here as well. I am recording. It's in secret. All right, so here we go. Confidence intervals. Do I want this one first? I guess I do. Yeah, those two were slides I was supposed to delete. Here we go. In a survey of 1,550 U.S. adults, 1,054 said they use social media website Facebook. Find a point estimate for the population proportion. Again, it sounds very complicated, but simply, you are just dividing the amount that use Facebook over the total sample. That's it. So what percentage of the sample uses Facebook? 68. So it's going to be 0.68 is p-hat. That's it. That's how you find your point estimate. Okay. All right. Moving on. Margin of error. So every one of these is going to have a margin of error formula. This one is back to z-scores. We're going back to the z-scores that we did before. Times the square root of p-hat times q-hat over n, your sample size. Okay. So the margin of error when you're using proportions of a population is this. Okay? You have it written down? Let's try one. So, here's your guidelines. First, ID the sample stats, n and x. Okay? Find the point estimate, which is what we just talked about. You have to make sure that it can be approximated as a normal distribution. You have to take your p-hat times your number of people in the sample, make sure it's greater than 5, and make sure q-hat times n is greater than 5. We skipped that section. We did not do section 5.5. That was in that section, okay? So n times p has to be greater than or equal to 5, n times q has to be greater than or equal to 5, and the same with the hat guys. Find the critical value z. So if I said 95%, what did we say 95% related to on the z-score? 1.96 or something like that? Remember that? I don't know if I'm believing Edie. Oh my God, it's on there already. How nice is that? 1.96. Never noticed that. All right. I know, Pete. I'm just double checking you. So to find your interval, you're going to add and subtract. Okay? Just like we were finding the confidence intervals before. All right, so you've got to find that margin of error. Here we go. In a survey, 2,241 U.S. adults in recent years, 1,322 say they made a New Year's resolution. Construct a 90% confidence level for the population proportion. So, what is my X and what is my N? What's the X and what's the N? Your N is your total sample amount. X is how many are doing whatever they're asking you about. So P hat. What is P hat? My point estimate. I'm going to round it. 0.59. So if P hat is 0.59, what is Q hat? 0.41. Everyone understand you're subtracting it from 1. Okay. So I've got my P hat, I've got my Q hat. My margin of error is going to be my confidence level, which is 90%, which is what? 0.645. Times the square root of P hat times Q hat over N, which is 2,241. Just type that in your calculator. That's going to give you your margin of error. I get 0.017. Okay, so we're going to add and subtract that. The P hat. So 0.59 plus 0.017, and you're going to have 0.59 minus 0.017. So our interval is between 57.3% and 60.7%. So if I'm looking at the actual population, and I pull somebody out at random, that's your interval, your confidence interval. Okay? To find the actual mean of the actual population. Make sense? Find that proportion of the whole population. It's going to be in there somewhere. You have a 90% chance of it being in there. Grant. So we're taking our margin of error and adding it to P hat, subtracting P hat. All right. So the figure below is for a survey of 800 U.S. adults between 18 and 29. Construct a 99% confidence interval for the population proportion of 18 to 29-year-olds who get their news from the television. So what percent get their news from the television? 27%. So our P hat is 0.27. What's Q hat? What's your N? 800. What is your confidence level for 99%?
2.576. Oh, sweet.
So, find your margin of error and find your interval. Go. I don't believe it. Yes, sir. We're back to the Z-chart. What did we get? Guys, it's not a long lesson. Let's keep on here. So 2.575 times the square root of 0.27 times 0.73 over 800. Type it in your calculator. What do you get? What's my margin of error here? I got 0.04. So if I add 0.04 to 0.27, I get 0.31. If I take 0.27, I subtract 0.04, I get 0.226. No? 23. Should round to 2 decimal places. So we are between 0.23 and 0.31, 23% and 31%. Okay, does that make sense? It's just another formula. I want you to make sure you have these in your notes when you use what? Okay. Everyone done writing that? Okay, let's look too quick. All right, minimum sample size to estimate P. So all we're doing here is taking, just like we did the other day, we're taking this formula and solving it for n. Okay? So I'm just not going to go through that. There's your formula. N equals p hat times q hat times the square of your confidence level over your error. And it's just a rewrite. It's just algebraic rewrite of that other one. If n is not a whole number, you want to round up to the next number, like we did before. Also, if you do not have preliminary estimates for p hat and q hat, you're just going to use 0.5 for both. So if you're not given p hat or q hat, use 0.5 for both. And you can still do an estimate of the minimal sample size. Okay. So in this first one, no preliminary estimate is available. So you're running a political campaign in which to estimate with 95% confidence the population proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3%. So that's your error. That's telling you how accurate, within 3% one way or the other. Okay? Of the population proportion. Find the minimum sample size. So we do not have a p hat or q hat, so we're going to use 0.5 times 0.5 times 95%. 1.645 over error is 3%, and we are squaring it.
Point.
We're doing a survey of people. It's not going to be 4.6. I get 751.7. So we should survey at least 752 people to get an accurate. What?
It says here that we're not any
Thanks, Pete. Pete.
What? You said it was for 0.95, right? Oh, yeah, that's 1.96. I forgot to test it.
I tell you what.
Great. Sorry. This is not true.
So that changes it a bit.
I just used the number.
All right. So that's how many people we need in our sample. Okay, now we're going to do it when p hat is 0.31. So it's the same idea, but we're going to have p hat times q hat. What would q hat be? .69, and this is to the second power. So you actually have a p hat q hat. So you're not rounding, you're rounding up to the next whole number. So even though it's closer to 913, you need to go to 914. Okay, does that make sense? And that's it, guys. Told you, short lesson. Short lesson.